So, perfect segue into what we're going to be doing today. So, I'm going to start out actually today. We're gonna kind of do something new. I've actually never done this before. Usually, I just kind of go over the lab. But what I'm actually going to do is we're going to start building a database in addition to the one we're doing from the lab from scratch here together. Um, and then I'm going to kind of show you how what we're going to do here applies to the lab, because the lab instructions have you edit an existing file, and sometimes probably this is the most like confusing lab for students. And so what I'm going to try and do is make it so it's a lot easier. Because what we're going to do is, instead of actually editing an existing file, we're just going to build from scratch. And that's actually what they used to do. And then they changed it to this other way. And I actually think they're getting ready to switch it back. So um, we're going to build a database on our own. We're going to start from scratch. And the whole purpose of this, I think, that will be useful is versus editing the existing file, it's going to show us how we create a table, but along the way, we're also going to be learning a little bit about design and a little bit about the concepts like the primary, foreign key relationships, because we're going to actually flesh those out and build them together right here. So if you have a question, feel free to throw it in the chat and I will see it because I have it up on my other screen, and we'll do this. I will often ask a question. Feel free to either unmute yourself and answer or throw it in the chat. And there are no wrong answers, so throw it out there, because a lot of times, I guess there is a wrong answer, but a lot of times an answer that's not necessarily accurate can lead to a really good discussion about why, and better understanding than if just the right answer is given. So the more people that guess or attempt to answer, the better. It's going to be, it really helps. Okay, so let's get started. So kind of what I thought would be really fun, as simple, because I kind of want something that's just simple. So what we're going to do is we're going to build a database for like a to-do app, like pretty simple. And we're going to start going along those lines. When we say to-do app, like think about just like, I have my little lists, that I need to keep track of. And so a couple of things as I was thinking about this, we want our database, and when we think about the database, basically for the end result of this project or this application, whatever it comes to fruition to be, we want it to be able to have multiple lists. So like if I'm a user, maybe I have a work list, maybe I have a home list, maybe I have a church list, maybe I have a weekend honey to-do list, right? So I want to be able to dynamically create lists. And then within each one of those lists, I just want things to do, right? So with that in mind, let's get started. So I'm gonna help us out right off the bat with the first table, right? And this is kind of like my personal preference. I'm a big fan of a person table. And what I mean by person, and we could call this a lot of other things. I like to call it person because it gives a lot of flexibility as far as what we can do in the future. But we're going to have a person table, and inside this person table, we're going to have things like a first name, a last name, and that sort of stuff. So what we're going to do is we're going to talk about creating the table, and then we will add more to design after we do our first table here. So our first table is going to be person, and let's build it. So, and this is directly applicable to the lab, because this is pretty much what the lab is creating tables. So the first thing we're going to do is start off with this statement, create table. And that's the nice thing about SQL, is a lot of this stuff is common sense in the way that we go about writing it. So we're going to say create table, and we're going to say person. Okay, pretty simple. And then we create some parentheses. And I always just like to create the opening one and then do a space. And now what we're going to do is we're going to say what kind of columns we want to go in this table. Now, if you remember, the first thing that we want in every table is our primary key. And the primary key needs to be unique for every row in the table. So in most cases, what people do is they create an ID column. It literally says ID. In a lot of like the web development world, you'll see it just go like this. It'll just say ID. And I actually personally do not like that practice at all, which we will talk about in lab 5 when we start to do joins. And actually we might even talk about it here a little bit. What I like to do and what a lot of people do is we create an ID that has the table name and then an underscore ID. and the reason being is that way you know when you're writing out columns exactly what ID that goes to. Because in the future, we might be combining tables together in various queries and stuff. So it's always nice to kind of know. Because as far as ID columns, there's no no context behind it versus like first name. A first name, you don't need to put person in front of first name because we can assume it goes to person or there's some sort of idea. So anyways, person ID, we put the name of the column we want, and then I'm going to give us a couple little tabs here, and then we want to specify the data type. And this is where some databases get a little different. In Oracle, we have a number data type. So I'm going to put number here. And additionally, we could specify some details as far as like what type of number we want there. But for now, we're just going to leave it because we want it to get to the max size. All right, so we have person ID, our data type, and then we're going to do one last thing, and we're going to create a constraint on that table. Let me make sure I got that right here. And a constraint is a way that we make sure our data stays accurate. So we're going to say constraint. Actually, you know what? Let's leave that one. Let's leave it blank for right now. Sorry. Don't mean to confuse you. We'll do it on the next one. So person ID. So now let's jump right in and we're going to do a first name. And we are going to create a column called first name and give it a data type of a varchar. And a varchar, for those of you programmers, is a string, so just characters. And someone asked, is there a set number of spaces that go between words? And the answer is no. Honestly, this is all about looks for me. So I just hit tabs. So it's all about how it looks, just to keep it clean. So what I like to do is I like to keep the column name and then the data types kind of out there. I mean, because here's the thing that's kind of weird. We're creating a table. We're defining a table. So I guess it makes sense to kind of put it in a table. If it's a little table inception, right? It's a table that defines a table in a way. So anyways, first name is going to be where we obviously hold first names. And so this is where we actually start to get into a little bit of the design portion of all this. So we want to store names, but how long do we want names to be able to be? And my common number is 60. You know, it's plenty big. And the reason we put this in here is because we don't want to use up too much space on our actual physical hard drive. So what this means is that people's first names can be 60 characters long. Okay, so a first name can be 60 characters long. It can't be any longer. And then what we're going to do next is we are going to create a constraint. And a constraint, like I started saying before, is how we constrain the data in our table. It's kind of where the frame comes from. So just to elaborate on that, it's basically what we're going to do here with first name is we're going to make sure that you can't leave that empty. Have you guys ever been on a form and it says like, oh, you must enter your email, or oh, you must enter your phone number? And you're like, well, I don't want to give you my phone number. Well, this is what they're doing, right? They're making it so certain data has to be in there. And rather than for nefarious reasons, we're putting it there because there's no point in having a person if it doesn't have a first name, right? So this is kind of how you, I guess, make sure your data is it's called data integrity, right? We want to make sure that we don't have trash data. And maybe it's even just for your end users, right? Oh, I forgot to put the first name. How silly of me. Well, instead of saving it and giving you that false sense of security, we don't even let it happen. And someone just asked, is that like a required field? Exactly, it's like a required field. So now we're going to define it. So we say we want to constrain this, and then we're going to give that constraint a name, and we're going to call it NN person 1. And then we're going to say not null. And that is how we basically tell it that it's a required field. And the way this works is the constraint tells it we're constraining the table, and then we give that constraint a name for reference purposes. Because, for example, let's say that I try to put a person in without a first name. It'll say, whoa, you have broken the constraint NN person 1, and then we can go find it and know what we did wrong. And then the constraint, so we say we're constraining it, here's the name, and how are we constraining it? Well, it cannot be null, and null means empty. So not null. First name cannot be null. We just made it a required field. And we're going to do this again. We're going to do the same thing for last name, right? So we're going to keep the same 60 character limit. We're going to say constraint. We're going to say NN, but this time we're going to call it person 2 because we don't want two constraints with the same name, and it actually wouldn't let us. So we're gonna make last name required as well. Now, what about middle name? Do you think we should constrain middle name? No, good. Lots of no's. And the reason we don't want to constrain middle name is because most people don't have. Well, I'm not gonna say most. A lot of people don't have middle names. It's not required. We don't want it. So we're gonna do the same thing. Varchar 60. And actually, I apologize. I have been living in Microsoft world for so long. Those should be varchar 2s. Technically, there is a varchar, but in Oracle, there's a thing called a varchar 2 that's better. So we use varchar 2s. All right, and we're not going to constrain this one. So if we're not constraining it, we're going to just leave this blank and move on. Okay, some other things that a person might have is a date of birth. And I like to call it birth date. And we are going to put a date there. Now, this is something where we get a little tricky. This is where we, as the database designers, and most of the time the specifications are laid out for us. But this is a spot where we have to stop and think, do we want to require a birth date? And in this case, I'm going to say no. We're going to put it there, but we're not going to make it required. And a lot of times you might put columns there in anticipation of something, but that doesn't mean that you absolutely have to use it. Like in this case, we're going to leave that we're going to leave that nullable, meaning that it can be empty. And we might not even put any data in there, right? We might just ignore it until maybe one day we add a feature where on your birthday, it shows a cake on the app screen, whatever. So someone asked, what's the difference between a varchar and varchar 2? There's really subtle differences that are really kind of crazy, that are really deep. In fact, I don't even know a lot of the differences. I know that the varchar 2 is more efficient in the way it stores data, and I just know to use varchar 2 with Oracle. Database systems like Postgres and MySQL, they don't have varchar 2s. They just have varchars. So yeah. You can look it up if you want. If you do a Google search, I'm sure you'll find it. But for right now, we're gonna not go over it. Okay, so some other things that might be in person, and we're actually looking pretty good. Now, this is where we're gonna do something just for the sake of simplicity, because normally I would actually, let's not. Let's do this. So we're gonna leave it like this. Okay. We're going to leave person pretty blank. And now we're going to create another table called, let's do this. Let's call it user account. Okay. And I'm going back and forth on this. Do we want to do this, or do we just want to have a person table? Tell you what, let's keep it simple for right now. It's our first one, right? We'll add some more later. We can always change this. So for right now, what we're going to do is we're going to add an email column to here. Let's make this 130. We're going to add an email column to there just for the sake of having one. Okay, so there's our table. Now I'm going to run this and see what we get. And now we get this table person created, right? So I'm going to come down here and I'm going to just say select everything from person, just so we can see it. And what do you know? There's our table. We don't have any data yet. But let's say that I made a mistake and I had a typo for whatever reason. So I'm going to change this to email. Instead of just saying email, I'm going to say email address, right? Let's say that I goofed up. Let's run this again. Oh, you'll notice I get this error and it says name is already used by an existing object. So tables are persistent, meaning that we just can't like recreate them. And the reason being is because we're working with a database. And if we just recreated it, we would lose everything, right? So normally what we would do is we would actually alter the name of this, but for the sake of lab one, because we don't have any data in there right now, we're in the development stage. We don't worry about losing any data. If you ever need to fix something, you have to drop the table first. So we say drop table person. So if I run this, it drops the table. And now if I try to run this down here, it'll say, oh, the table doesn't exist because we dropped it. But now I can recreate it with the new names, and there we go. So what I always do, and in my script, I put drop table right before it, because most of the time if you're running a script that's going to create a bunch of tables, you're working on it. And then that way when it runs through the whole script like this, it drops it, creates it, and then so every time you run it, it drops it and creates it. If you want to run the whole script, you click this run script thing. If you want to run one command at a time, you can actually push Control Enter, and it runs just the query that your cursor's on or after. So I just do Control Return, Control Enter. Yeah, so there you go, Control Enter. Runs one statement. F5 runs the whole page. All right, so we have our person table. It's working. It's great. I'm actually going to take this off because it's just can be email. Okay, so now what we want to do is we want to build. This is where we start to get a little interesting. So we're going to build a list table. And like I said, me as a person can have multiple lists. Okay, so let's see how we do. Create table list, right? Pretty easy. What should our first column name be here? What do you guys think? What should our first column name be here? If you were doing this, primary key, list ID, perfect. Someone said list name, and we are going to add a list name. But I always like to put my primary key first thing in the table, so it's right there. Just like on your spreadsheets, how the number 1 is always on the left, like your row number. That's essentially what the primary key is, and so we always want that over on the left. Technically, it could be anywhere, but we like it. So let's do this. We're going to build a list ID, and we're going to give it a data type of number. Now, what do you think we should do next? And someone said list name earlier, but this is kind of a trick question because there's something we need to add here that doesn't belong in list, hint, hint, that uses it to connect to something. So foreign key, perfect. Foreign keys right there. And so for our foreign key, what are we going to connect this to? And someone said it, person ID, exactly. So we are going to put a person ID right here, and it's going to have a data type of number. Okay, now what we're going to do right now, someone already said this, so we're going to give this a list name. Now we're going to do this a varchar, and we're going to say that list names can be 30 length there. Now, we're not done with this because there's one thing that now we have to do to make all this work. And I was waiting to do this until we had two so you could see how it all works. So up here in our person table, we actually never defined a primary key. I mean, we have the column, but we never actually said what we want that primary key to be. So we're going to add a little concept here because that table worked perfect. There's just not the primary key to it. So what we're going to do is we're going to make our person ID the primary key. Now there's a couple terms here. So there's what you call an inline constraint and an out of line constraint. And an inline constraint is constraints that were in line with the column. An out of line constraints are the ones that we are about to define, which are not. So we're going to build a constraint and we're going to call it PK, person, stands for primary key, person, right? It's the person's primary key. And then we say primary key. And then in parentheses, we say what we want the primary key to be. In this case, person ID. Okay, does that make sense to everybody what we just did here? Because we defined our column, but we need to designate it as the primary key. So that's what we did here. So now remember, we have to drop our person table and then create it again, this time with our primary key. There we go. So now our person table is actually done. And so now we can come back here. So we have our list ID, person ID, and list name. Now let's constrain this table up just a little bit because you know, we want to constrain just a little bit. Is there any reason we would have a list that's not attached to a person? Nope. So what should we do to the person ID column in the list table? Not null, exactly. So someone says, what if you wanted it attached to multiple people? And that's a good question. We'll get there in just a minute. Okay, so we have a list, and we want to make this constrained because there's no reason to have a list that's not assigned to a person. So we're going to say NN list1 to give it a name, and we're going to say not null. Perfect. Is there any reason why we should have a list without a name? Do we want no, exactly, because if we're building our application, that's something that the programmers are going to, you know, we want to make sure it's there. It's something we want to be able to count on. So then we're going to say not null. Perfect. And then the last thing we want to do is well, a couple things, but let's build our, actually real quick, before we build out the primary key and such, someone asked, what if we wanted this attached to multiple people? And if you remember, I think in week 1 we talked about this. Maybe some of you guys haven't seen the video. Would we want to do something like this? Would that be something that would be beneficial, do you think? Getting some no's, which is really good. Perfect. So let's say we did want to make this attached to multiple people, because I actually, you know, I think that's a great idea. I think it's a great idea to have something attached to multiple people. So what we're going to do is we're going to leave this called person ID, but we're going to pretend that this is the owner of list. Okay, because I think when we build this, we want at least one person to kind of be the owner, right? Or the person who created it, the one who's in charge of the list. Now we might be able to give people access to this list. And so anyways, let's finish off the list table here, and then we'll actually make it possible to assign other people to this list, because that's a really good idea. That way, if you make a grocery list, like let's say my wife makes a grocery list and she says, hey, can you stop at the grocery store on the way home? And I say, yes. And she says, oh, get chips. I like Sun Chips. She likes Doritos. I get the wrong chips and I say, well, you didn't specify, so I got a Sun Chip. That way she can say, nope, I sent the list to you. I'm going to chew your butt now because you got the wrong chips. So anyways, all chips aside, let's finish this table. So let's say this is all we're going to have for right now. We're going to have a list ID, person ID, and a list name. What do we need a primary key, right? So let's build our primary key out here again. So we're going to say a constraint. And earlier someone asked, can we build this constraint in line up here? And technically, I think the answer is yes. You just don't see it happen very often. And I couldn't tell you why. Okay, so constraint list, primary key, we want it to be list ID. Okay, so there's our primary key. Now, what's the other thing in here? What's our other key? We have our primary key. What's the other key that's in this table? Foreign key, exactly, the foreign key. And what is our foreign key? Person ID, perfect. Yeah, so usually the keys are done out of line. And I think that's just simply to make it easier to read. And actually, now that I think about it, Oracle might not let you define a primary key in line. I'm not 100% sure on that. I get confused between that and SQL Server. And it might be because I've actually only ever seen it done down here in Oracle. I'd have to test it. We could test it, but we're running short on time, so I'm going to keep trying to keep us busy here. So just like we talked about, the other key in this list table is our person ID, and it's the foreign key. And it's foreign key because it's the data that doesn't belong here, because it's technically going to contain data for a person. But that's how we tie it together. That's our only overlap. So anyways, let's build our primary or our foreign key. So the way we do this is we say constraint, and I'm going to say FK for foreign key, list one, because we can have multiple foreign keys. And then we say foreign key, just like we did primary key. Now this is where things get a little different, because not only do we need to specify which column in the list table, but we need to specify what table and what column in the referencing table it references. So that's like that's kind of how weird how you say that. So they call it referencing. So the first thing we do is we specify the column locally, the column and list that we want. So in this case, it's person ID, right? So we have our person ID is the column right here. This is what we're talking about when we have it there. Now what we want to do is we want to tell it where it looks to. So we say references, and then we say the table name. So in this case, person. And then in parentheses, we specify the column name. So in this case, person ID. And now you can see why it kind of helps to have the person there in front, because we're going to start mixing these up a little bit. So anyways, let's see how we did. I'm going to run this real quick. Oh, and we have a boo-boo, and it says we're missing a right parentheses, and that's because we are. So let's add another one and run it again. And now table list is created. So let's just make sure, and I mean, it worked, but I just like to see them when I'm done. We have our list ID, person ID, and list name. So there we go. We have our person, we have our list. Now what we want to do is, like we just talked about, we want to make it so we can add people to our list. We want to give them access, right? Okay, and someone asked a question. Let me get this real quick. So why isn't PK list 1? That's a good question. And the answer is because there's only one primary key. So there's no real need to add another one there, because we're only going to have one. And actually in the lab, you'll actually see that they do list this like this. And I think that's just to be standard. I'm not quite sure. I've always done them like this, but ultimately the beautiful thing is that none of this really actually matters that much, because it's just a name. And the only reason we care is because when we break this constraint, when we violate, that's the right word, when we violate this constraint, it will tell us which one we violated, which is really helpful. Yep, so if there were multiple foreign keys, we would label them 1, 2, 3, and we're actually about to do so right now. So we're going to create another table because we want to be able to share our lists with people. So we're going to create a list access table. Or, you know, or does anyone have a better word? Because basically kind of what we're getting at is like a share a list. You know, list access is pretty good actually. Let's stick with that. So we're going to build our list access table, and this is kind of where we're going to give people access to our thing. So we say create table list, and to be correct, we are going to put, and I get a little confused sometimes, we're going to call list access like that. Create table list access. All right, and the reason why I don't do camel case in databases is because I don't like to, they all end up being uppercase anyways, so the lowercase actually makes more sense, because otherwise this ends up being like this, and so the camel case doesn't do you any good, but this does. Just as an FYI. And someone also asked, why is list blue up here? That's just because the syntax is using it as a reserved word. It thinks it's like a syntax word. Yeah, kind of like a command. Just like if you've ever programmed before in like integer, you know, words like that are always going to kind of color code on these hides. But if it works, it works. The reserved words, you can find a list of them actually for Oracle. So it just recognizes this word as like number or so forth. And there's some that you can't use, but there's others you can, obviously, because we use lists just fine. Okay, so list access. The first thing, again, I'm sorry if this gets redundant for a lot of you, but it really helps. What's the first thing that we want to, what's the first column we want in here? List access ID, perfect. Primary key, you guys are nailing it. List access ID. And what data type are our primary keys? Numbers, perfect. Technically, they don't have to be, but pretty common that they are. In bigger databases, they actually use strings. But anyways, list access ID, number. So now what we want to do is, someone asked, do we have to specify to auto increment? There's a MySQL person. And the answer is we kind of do something a little different. Oracle is a little bit more powerful, which means it's a little bit more complicated. We're going to get to it here in just a minute. So someone said person ID, which we are going to add a person ID. And I'm a little OCD about the way that I put these in here. And so, and I'll tell you why here in a minute. List ID, there we go. So the reason I'm putting list ID first is because we're giving access to a list, if that makes any sense. And again, all this really doesn't, it's tomato. But the reason I like list first is just simply when I'm looking at the table, like with the data, like if I was sorting it by, who has access to which list, the list comes first, then the people attached to the list, if that makes sense. So I like to organize in the way of like that, because we'll have fewer lists than we will people, because multiple people can be attached to a list, if that makes sense. So I like to go like order of smallest to largest as far as quantity or organization. Okay, so our list ID, what data type should list ID be? List ID, number, perfect. And is there anything we should do to this one? Should we just not know? Perfect, you guys are getting it. So we're going to constrain it. We're going to say NN list access 1. Now, if your constraint names start to get too long, you can slim those down, because like I said, it doesn't really matter too much. So we could do something like that, but for the sake of just being consistent, we're going to do that. And we're going to do the same thing here, because we have our other foreign key here. Okay, so here's a question. Is there any other columns you guys would think would be nice to add here? And I guess something to think about. And inline constraints don't actually have to be named. That's a great question. And the answer is no, but if we ever violate them, we want that name so we know what was broke. Okay, so I asked what other columns in here, and someone said a list name. Well, we actually already have a list name here, and we're tying to those lists. So if we put list name here, we would have to change the name of the list in 2 different places. So we really don't want to do that, because then we'd have to do all this trickery to make sure, like, I changed my grocery list to shopping list, and we'd have to change that twice, and it would be stored twice. And yeah, it's not ACID compliant. It's not normalized, is another way to put it. And then someone said the person who's getting access, and that's actually what this person ID does here, is it's who gives it access. Because remember, we already have the owner. We're kind of just saying who has access. So I'm going to give a little hint here. And again, we're going to keep this simple, because 2 ideas that I would think of is, do they have rights to view only or edit, which we're not going to go over because that gets a little bit more complicated. But a little bit more simple element we're going to add to here is, what if you want to take away someone's access? Right? Now, a lot of people would say, well, just delete the row from the table. However, it's never good to delete data, because then you lose that. Let's say that we give access to somebody, and then our system's built in such a way that when we take it away, it just deletes it. Well, when we delete that, all history of that has been gone away. So let's all of a sudden say, like, I open up my to-do list and it says, like, there's all these things in here, like, that are not good, and someone's playing a prank on me or whatever. Well, yeah, we'd never be able to track that. So then someone says, access check, restriction, Boolean is ID valid. Those are all really good ideas. And in fact, that a lot of those is valid would work. But we're going to take it a next step farther, because what if you give someone access and then you take it away and then you give it back? We don't want duplicate rows in our table. because we might add some logic to say that, access can only be, whatever. So let me give you a hint. This is what we're going to do. We're going to do something a little different. We're going to say start date, and we're going to give it a date, and we're going to constrain that so that it has to be there. And then we're going to put an end date. And this one we're going to leave so it can be blank. Perfect. So now you can see what we're doing is we're making it so we can have a rolling history of when people were added to a list, when they were taken off a list, when they were re-added to a list, when they were taken off a list. And the other ideas would have worked, but we would never have had those timestamps to go with it. But when we have a start date and an end date, what else is cool is you could say, look, I want you to have access to my list, but only from Saturday to Monday, right? Stuff like that. So that's how we're going to do that. We're going to put start date and end date. And we're going to say dates, because the other thing we could do here is we could actually make this a timestamp, but we're not going to get that complicated. We're going to say, look, you pick a date, and that's the date that they have access to. We could restrict it clear down to the time level, but we're not going to do that. All right, so now a couple other things we need to do here is we need to declare our primary key. We need to define it. So we say constraint pk list access primary key list access ID. Sorry, I'm going to move just a little bit quicker because we need to get to where we talk about the lab just a little bit. So just like what was asked earlier, could we put multiple foreign keys? And that's what we're going to do here, because now we have list ID and person ID. So we're going to say foreign key list access 1 is a foreign key. Okay, what goes in these parentheses? We're defining a foreign key. List ID, perfect. And that again references the local column name that we want to apply the foreign key to. And then we say references. All right, and what goes here? Perfect. The table name that we're referencing, and then the column within that table that we're applying it to, that we're referencing. So list says list table, and then inside the parentheses list ID. So that's what that's going to reference. And then finally, we're going to do that one more time. This time person ID, and it and that text is hard to see. There we go. Okay, let's see how we did. List access created, so we're good. Let's make sure just by doing this. Great. So okay, now for right now we're not going to dive into tasks, simply because I think actually, you know what? Let's do it real quick. If we can do it in 10 minutes. So someone said tasks earlier, and I thought that was a great name. So we are going to do tasks. We're going to say create table task. And I always like to name my table like singular instead of lists, just list. And it's a personal preference. So we're going to say task ID. It's going to be a number. Let's give it a sequence, because we want to, before I do that, I'm breaking my own rule already. List ID is a number. And right now we're going to make the assumption that people we share the list with only have read access, okay? So we're not going to make it so we track who wrote the task and all that kind of stuff. We're going to just say that you can share a list, but it's read access only. So list ID is a number, and then we want a name. And what's a good size for a name on this? Let's say 60. You know, most of these have notes. You know, and for the sake of being simple right now. Oh, and I'm putting varchar instead of varchar2 there. Did I do that anywhere else? Nope. Yep. Let's say you can make a description that's 250 characters in length. And then one more thing that we might want is a sequence. And what I mean by sequence is we want to specify in what order are our tasks done. And someone asks, is there a way to know which primary key and foreign key in a table without looking at the code? Yes, and we'll talk about that in just a second. So real quick, I'm gonna just leave this pretty. Let's do this. Let's do it right, I guess. Constraint, and then task 1. Not all. We're going to let you leave that blank, but we're going to let you leave the sequence blank. Maybe you don't care what order it is. Okay, so let's do that. And then we need to obviously define our primary key. So constraint, PK, task. Sorry, I'm going a little fast so we can get to other stuff. Okay, let's see how we did there. Oh, what did I do? Oh, I guess it helps if you spell constraint right. You'll also find that Oracle errors are not always the best. Like, for example, I said I was missing a right parentheses when really constraint was misspelled. So be aware of that. It happens a lot. It's pretty commonly known that Oracle's error codes are sometimes annoying. Okay, and there we have that. So now what I'm going to do is I'm going to make this whole thing rerunnable by saying drop table task. And this is actually pre-warning, just so you know that I'm not crazy. This actually is going to make an error, and I want it to. Because we're going to just say, oh, we're going to drop all these before we create them, right? Well, let's run it and see. And here we go. When we say drop table list, it says unique primary keys in table are referenced by foreign keys. An attempt was made to drop a table with the unique or primary keys referenced by foreign keys in another table. So now that we have built these primary key or these foreign keys specifically that reference other primary keys, we have hierarchy, right? A person owns a list. So let's say that I tried to delete the person table. What do you think happens here? The answer is it's not going to let us, right? As we just saw. So that's why, and the reason I wanted to show you this is that's why we have that cleanup script that you guys are going to be running pretty consistently, because what the cleanup script does is it deletes everything in order. So we're going to say drop table, because what we actually have to do is we have to go in reverse order. So we're going to say drop table task. Then we're going to say drop table list access. And then we're going to say drop table list. And then we're going to say drop table person. And then I'm going to get rid of all these. And then we're going to try it again. And there we go. And now what's cool is I can rerun this over and over and over again, and all it's doing is it's deleting everything and recreating it, right? So that's essentially what you're going to be doing with your code in the course of this, in the length of this class. We will have written all the code to completely erase it and then recreate it, right? Which is very good practice to do, because the hard thing about databases, you'll see a lot of people create it. They'll write this code and they'll say, well, it's in the database, and they'll close this, say don't save, and they're gone. And then if they ever need to create, like, let's say a sandbox, or let's say their database computer, their server dies in a fire, a California fire rips through this data center and destroys their database. So it's just good practice to keep it in a script that's easily able to create your database. So now we're going to go back to a question someone had earlier about auto increment. And the reason we're going to talk about this is because sometimes, and you'll see this in the lab, we actually have to create data before we can do certain things, which we'll talk about here in just a second. So what we're going to do is we're going to insert into a person. We're going to create our data. We're going to do our first little insert, and which we will come to talk about here in just a minute. So insert into person, and what we're going to do is we're going to say insert into, actually before we do that, let's talk a little bit about the person table. So let's say that our person table also holds like our users, right? And let's say, well, actually, you know, we'll talk about it when we talk about the lab. So let's do an insert real quick, just so you can see one. So we're going to say insert into person. I mean, believe it or not, it's that simple. And then in parentheses, we're going to say what we want to insert into. And I like to always just go in order. So person ID, first name, last name, middle name, blah, blah, blah. So we're going to say person ID, last name, first name, middle name. And what else do we have up here? We had birth date and email. Now, I'm going to skip birth date for now and just put this, because if you remember right, birth date was nullable. We said it's nullable. Same thing with email, but we're going to put email in there. And then what we do is we say values. And then in parentheses, we say what we want. Now, this is where that question came in, the auto increment. How do we make it count for us? Because we don't want to, I mean, we could do this, right? We could put person ID is 1, and then we could say person ID is 2. But when the computer's doing all the inserts, you know, people are on the computer and they just fill out a web form, who's tracking that? Well, the computer needs to. So there's another piece to all this, and those are called sequences. And a sequence is just going to count for us. So we're going to create or replace sequence, and then we give it a name. And we always do it like this. We always say I think it's more like this, person underscore S1. Person sequence 1, and then we could just leave it like this, right? We could just say, and I don't think we can do the replace in Oracle, so we'll say create sequence. So we can do this, right? We can just say person S1 created. Now the way sequences work is if I then said select person underscore S1 dot next val from dual, what do we get here? Did I do that right? There we go. So if I say select person underscore S1 dot next val from dual, I get the number 1. Now I'm going to just keep running this, and you'll notice that it just sits here and counts for us. Okay, and that's what we want it to do. And then if I ever want to get the current value, I can do select person underscore S1 dot curval from dual, and you'll notice that I get 9. But if I do this a couple of times and then run this, it's 11. So that's the way these sequences work, is 1 counts up, the next val counts up, and curval pulls the current value. Now someone asked a great question. They said, what does from dual mean? Well, we select from a table, right? Normally we say like select everything from person, select everything from list, or select something from person, select something from list. Well, in this case, we want to select something, but it's actually from not from a table. It's actually just from nothing. And so dual is an in-memory table. So I can do something like this. I can say select hello Nimesh from dual. Now your hello Nimesh isn't anywhere in our database, but because I'm selecting it from dual, it actually just puts it into memory so we can output it. Is essentially what that does. So it's kind of like a fake table from dual. So good question. It's often used as just a way to demonstrate stuff, but it's also used as a utility, which we come across in the future. All right, so we have our person sequence. Now, one other thing I want to show you is that we can specify where we want this to start. So let's say we want to start with 1001, which is pretty common because like a lot of people use the IDs as like, I don't know, student IDs, stuff like that. And maybe you don't want it to start with 1001, or maybe they use a sequence to increment student numbers, right? We all had student numbers. And so now we have to drop this. So we're going to say drop sequence underscore S1. Sequence dropped. So now if I run that and say select the next val from dual, you'll notice that we get 1001 and then it counts up from there. Right, so I'm going to leave mine starting with 1 for the sake of simplicity. The ones in the course will start with 1001. And what we're going to do is we're real quick going to create our sequence for each one of these. So we're going to say create sequence. Oh, I'm having a rough go typing today for some reason. Then finally our task. Okay, now we're going to ask a trick, not a trick question, but an advanced question. We're inserting into person ID. What should we put right here to make it so it auto increments per se? So it tracks for us. What should we put here? Next val, perfect. So we're going to say person underscore S1 dot next val. And that will give us our person ID. Now, I'm a big fan of Lord of the Rings. So we are going to say that the last name is Baggins. And let's use Bilbo. Now we put middle name right here. And because we specified it, we have to have a value there, but we don't know his middle name, so we're going to put null. And we're going to say his email is bilbo.baggins@lotr.com. All right, so in our insert statements, these match up just in order. So the first one here's the first one there, second is second, third is third, and so on and so forth. So let's run it and see how we did. And we got something wrong. So it says the sequence does not exist. Did I recreate that one on accident? I don't think I ever reran this. There we go. Let's try again now that it actually exists. And we get one row inserted. So now we can select everything from person and we get data. Woohoo! All right. So there we go. Now, let's real quick, and you could do that on and so forth. But real quick, actually, you know what? That might be a good place to stop. What time is it? 6? Yeah. All right. Does anyone have any questions up to this point?
I had a question.
Yeah.
So I did ask you, but you never went through it. Is there a way to find out the primary key and a foreign key without looking at the code?
Yes. So that's what I was just glad you reminded me. So now that we've got our tables created, let's say that, you know, we didn't make these tables. Let's say that they're gone, like we didn't ever see the code. We want to see what these tables are designed, because a lot of times, like especially if you're like me, the database actually for a lot of the products that I manage have already been built. Like our sys, you know, someone else created that, you know, and I can do little things to add customizations to it, but for the most part, it's already been built and I'm in charge of pulling data out of it. Well, in order to do that, in order to make customizations, in order to run analytics, I have to understand how the table is designed and that sort of stuff, just like you asked. So the easiest way is to run a describe, and you can type it all out. I just often do a DSC person. And this doesn't tell you the primary foreign key stuff, but what it does tell you is the data types. So what I often do is I pull up this, and most of the time you'll be working in an IDE. And the nice thing is, let's show you this way real quick first. So let's refresh, obviously. Refresh. There it is. Okay, and it's there. Okay, so we refresh. So like most of the time when you're working on databases, you'll be in an IDE, and you can actually kind of browse this stuff, and you can actually quick DDL it and copy it to a clipboard. You can just pull up the table and you can see the constraints. So a lot of times people will look through it this way. And so here you'll be able to see your primary key and foreign key and all that kind of jazz. And in SQL Developer, it's a little bit harder than others. But honestly, for the most part, you can make assumptions, and that's what I'll get to here. So a lot of times I'll just say describe person. And let's say I'm trying to put together, you know, person and list, and, you know, and I'll describe list, and, you know, it's pretty easy to make the assumption, because if the person's designed the database right, it'll look a lot like this, right? It's very rare that you see them. And obviously, if they're really messy, you might have to just go look at the code. The nice thing is it's super easy to get. Like in this case, let's say I don't know about person. I can actually just pull up the SQL right here to actually see how it was created. You'll notice that it looks a little bit different than what we did. And that's just because it's got all the tech stuff attached to it that's default. But you'll be able to see the code here. Good question. But for the most part, I usually just use the describe command. And there's actually a way to select the DDL out of here, but it's kind of complicated. And so I usually just click through there. Someone asked, can I upload this to Slack after? And absolutely. Actually, after this, with this video, I will post a link to the course. I kind of have like a Git repository that I put a lot of examples in. So I will send you a link to that GitHub repository. All right, so we've got to the point where we can create tables, we can insert data. And real quick, does anyone else have any questions? Otherwise, we got to hurry because I want to cover a lot of the lab. Someone asked, is it necessary to put a comma on the next line, or is that preference? That is preference. You could put it after, but I personally like it like this because it's just really all neat. And the rule for a semicolon is the semicolon comes after every statement. So like, for example, this create table is a single statement. And so there's one semicolon. Create sequence is one statement. And like when I hit control return, that's kind of how it determines, like, for example, to run create sequence and not create table, because it actually looks, it'll say, oh, go until the previous semicolon. Okay, got it. Boom. So good questions, good questions. Real quick, let's dive into the lab a little bit because I really want to explain a little bit of the difference between what we did and kind of what the lab's going to have you do. So in the lab, it's going to give a lot of instruction about how to copy some files and edit those files. And you know, if you want to, feel free. In fact, I'm going to post last semester's recording of Lab 2 just in case you want to follow the instructions. And ultimately, you're going to end up with the same thing. That's a beautiful thing about this database stuff is there's not even really a different way to do it. It's the end result is always going to be the same. And that's what we're going to check is the end result. If you have the tables there and they all have the right columns and they all reference the right tables, that's all that matters. And it doesn't matter if you use his file or create your own. So real quick, I want to go through the instructions. So it says setting up lab directory 2. This is where it will talk about copying the files. And like I said, I don't want to go over this because it's in that other video, but I'm actually going to recommend that you just start fresh with your own files and do exactly what we did. And create them from scratch. And I'm going to real quick kind of like walk you through system user real quick. But real quick before I do so, if you choose to follow the instructions, I want to clarify these just a little bit. This tutorial for editing a table to creation script is kind of like a function, meaning that you can apply this over and over and over to each one of these tables that you have to do. So essentially this tutorial is like insert those steps here, 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 here. And like I said, that can be a little confusing editing someone else's. Like I said, I actually think it would be almost just as fast to create your own from scratch. You can always look up the existing file if you need help or whatever, or just post in Slack. Honestly, I think the way you guys were answering questions, you'll actually be just fine. There's the only real tricky part is when you have to insert some of the data, which that's what we're going to talk about. So system user lab. So the step one is we want to create the system user lab table. Now each one of these will have these nice tables of tables, like I kind of joked about earlier. And that's what we're going to do. So we're going to create the system user lab.sql file. So just know that I'm looking at this. I'm going to swing it over here so we can see our VM. So I'm going to open up my file browser here. Go into data, 225, Oracle, and we're in lab 2 now. It's crazy. And what I'm going to do is I'm going to create a new file. So I'm going to right click here and say create new text file. And just to show you again, I'm going to right click, create new text file. And then I'm going just to create apply Oracle lab, or sorry, going crazy here. System user lab dot SQL. Basically, the name of the table is the name of the file. So I'm going to create that system user lab table, and I'm going to open it here. Now, when you open it in KWrite, as long as it's got the .SQL file extension, it should automatically know that it's SQL. You can always change it if you want later, though. And I'm just going to give a little comment here. Comments are good. The more comments you have, the better. And I'm just going to say system user lab SQL. So now, real quick, I'm going to show you one thing. You'll notice that we already have a bunch of tables. We already have a system user table. And so the question often asked is, well, why are we building another one? Well, the idea is to give you, we're going to build a duplicate copy of all those tables that are created already. We're just going to put underscore lab in all the names. And so if you do the traditional instructions, you just literally go through the file and add underscore lab in a lot of different places. While it is beneficial, sometimes I think you lose the quality of just doing it from scratch. And I don't think it saves any time because you're trying to muddle through someone else's code versus you can kind of just do it simple yourself. So in this case, what we're going to do is we are going to write our own. The first thing we're going to do is we're going to say drop table system user lab, right? Just to make sure that we start fresh. And then we're going to say create table system user lab. And we're going to pull up this table here, and we're going to go through and give it all of this column name and the data type. So this is the constraint. You'll notice this is the constraint. And then the data type. Now, one thing I'm going to say right now, I don't know why they did this. If it says integer, they mean number. If it says string, it's a varchar 2. Okay. And then it says the size. If it says maximum, that means don't worry about it. Just leave it. So real quick, we're going to go through and build this one. So just know that I'm looking at this right here. I just got it on my other screen. So we're going to create table. And we're going to say, okay, the first one is system user lab ID. And it is a primary key, but the data type is an integer, which means number. Okay. And then we have system user name. And it is a varchar because it's a string. So we're going to say varchar 2. And the data size is 20. And then we're going to say system user group ID is an integer, which means number. And we're going to say system user type is a number. It says integer, mean number. Then we have first name, which is a varchar 2, 20. Middle name, varchar 220. And yeah, if it brings up the list, you can just click it if you want. It's like I could just do this, hit return, say 20. So now this is kind of where we're going to hit something a little bit new. That's kind of like where the lab gets just a tad tricky. We're going to have this created by column, and I call these who audit columns, right? And the reason I call those who audit columns is it tells us who, what, where, and why. Really just who and when. Because we can track who edits every row in this table and who created it. And then we say creation date, and it's a date, and then last updated by. Last update date. Now there is the first little bit. Now I didn't do a lot of the not nulls, so let's And I clicked a button that I shouldn't have. So while we wait for this to load, let's go back down here. So I didn't do any of these not null constraints, which we would want to do. And it tells you the foreign keys, or if it's not null. So like in this case, system username is not null. So let's real quick do that one as an example. So we'll say constraint NN right? Like that. And those get a little bit long. And probably what's really nice to do is on all those not null constraints, you can copy them and put them in there. Now, real quick, what I want to show you is when you're creating those, it's there is a good example. So if I open up the files here and I go back to the Oracle folder and go into lib1 and into create, this is essentially what we're going to do, but we're creating system user lab instead of system user. So if you ever get confused, you can open up this and see the exact code here that they're using to create the other one, because we're going to do the same thing, just a couple differences in names. So like in this case, I can kind of have verify my work per se to do this. So on the, or you can, once you get familiar with it, you could copy it if you wanted to. Essentially, we have a perfect example just of different named tables. So anyways, you're going to go through here and do this. And I'm going to real quick, we are very quickly running out of time, but there's something I really want to get to. Oops. Let's recopy that. We're going to say this is for, oops. Why they ever decided to put numlock on a keyboard is beyond me. 4, 5, 6, 7. And then we need to do our constraints for our primary key PK system user lab. And you'll notice that they do ones, and really it doesn't matter too much, but just to be consistent with them, I'm going to put it there. Now remember, this is where a lot of the confusion came from, because a lot of people would copy this over and be editing this and they'd miss little things. Well, if you're building it from scratch, I think it reinforces the idea that like, oh, I named this column. You'll notice when I highlight that it highlights the other one. That's perfect, because that's exactly what that means. And then this system, oh, nope, it's, so this one, so this is where we're going to say who created it. And this is where things get a little weird. Okay, so in this case, what we're doing is we are going to, and let me show you the picture here, created by the foreign key. And actually you'll want to pull up this because we don't build all the constraints right now. This is kind of like the end result. So you'll notice like group ID, we don't build the foreign key there yet. But created by, this one's kind of the trickiest one, because created by, if you look at what it references itself. So essentially what we're saying here is that created by is going to have it's going to reference system user lab. So this is kind of a catch-22, because let's build this here real quick. So created by references system user lab ID. right? So there's that one. And I'm actually going to take and just copy this guy here, paste him, change the number. But instead of created by, we're going to do last update did by. And it's going to be the same thing. It's going to reference a system user, essentially. So, and then let's put our closing parentheses and semicolon. So we could run this, and basically, let's say we ran this right now. Okay. If I tried to insert into this table, it's not going to let me because last updated by needs to reference someone here. Okay, so in this lab, let's make sure, I want to make sure that they're all there, that there's nothing goofy real quick. Does that make sense to everybody what's going on with the created by and last updated by? How it references itself? Is it confusing to anybody is a better question. Okay, so I guess to put this in perspective, let's say we wanted to track which person created which person. Or in this case, like a system user. So like this is Netflix, or not Netflix, this is Redbox, right? And let's say that you own Redbox in its early days. And let's say you hire some high school kids to be your cashiers, your clerks. Or, you know, think back to your Video USA days. I don't know if anyone still remembers those days. But let's say that all of a sudden you see that there's someone new in the database, a new system user that has admin privileges. Do you think that it would be beneficial to know how they got to be there, when they got to be there, who gave them admin privileges, those sort of things? And that's exactly what these do. It tells us, okay, who created this record? When was it created? Who last updated this record? And when was it last updated? Right? So let's say that I make a system user for myself. You know, my user ID is 1. My username is Tanner Crook, right? Created by would be system maybe, you know, and that's kind of where this catch-22 comes in, because you'll notice that created by, until we get at least one record in there, no one can be in the created by field. So who created it? So what we do is we create a one row in the table called like sysadmin or something like that, and that's who does it. So I'm gonna real quick make sure that because they changed this, and we used to do it in there, but I think they took it out. Nope, here it is right here. Oh no, let's see. Okay, yeah, so we never add it. We never add it. I don't think we ever insert data into there. But let me make sure real quick one more time. All right, yep, so we never insert data until next week. So that's good. So you can just kind of create the table and move on that way. Now, so you'll just follow those, look at the file, look at the web page to see the specifications here. And remember, we're not doing all the constraints right now. I wish that they didn't have these. It actually kind of gives you a little bit of how it should look when it's done. So the way this works is you create it, and every step will have this. You should use the following formatting to verify the end. So I usually just take and copy this and put it right after I'm done here. And then that way when we run it, it actually shows you that you got it correct, because then what it prints out, you can look here and say, oh, yep, we got it. Now, one other step that's going to be in there is the sequences. So we're going to also want to create a sequence, and that's in there. Like I said, if you want a really good example, pull open the this file. So again, that's under data 225 Oracle lib1 create. So like if we're doing a system user, I would pull up this file. Now anything that kind of looks like this, you can ignore. It's like anything that has like begin, end, all that kind of stuff you can ignore. But you'll notice that that same query is also right here. The only difference is it's got this weird table name thing. So, and really, as long as the table's there, that's all that really matters. Because at the very end, it will actually query all of them. So really all you need is the table, the sequence. But one thing that I'm going to show you real quick is there's a couple little bonus things in here, and they're in the instructions. But the indexes, and we didn't talk about an index, so I'm going to talk about those real quick. So real quick, let me create sequence system user lab S1, start with 1001. Okay, so this the sequence, an index, sorry, I'm starting to get a little tongue-tied. An index, what an index does is it helps our database be faster. And I don't want to get too crazy about it right now, but just know that whenever we index a column, what we're doing is we're saying, hey, look, database, I'm going to use this a lot to filter on. So when they index it, you know, I don't know if there's very many of you, but you know how on the early days of the library, if you wanted to find a book, you know, before computers, and yes, the on statement does need underscore lab. Thank you very much. Now, if you look here, system username is still system username, so we leave that one. Good catch. But if you remember in the early days of libraries, we didn't have computers to help find them. You know, if you go to the library and you're like, oh, where is X, Y, or Z? Instead, what they had was a big filing cabinet that was the indexing system. You know, a lot of people had their own way of indexing. But essentially what it was is a way to clump different records together, different files or, you know, cards. I'm sure back in the early days of universities, before they had computers and databases, they had giant filing cabinets with all of like students like you and me and all of our records. And so a lot of times, you know, it's a matter of how do we index this, and most of the time it's probably by last name. Is it by cohort? Is it by start date? But the beautiful thing about databases is we can do all of the above. So in this case, what we do is we say, look, create an index on the username field. And so what it does is Oracle says, okay, and it creates all this background magic. And that's all I'm going to say about it right now. Just kidding. I'm going to explain a little bit about what it does. What it does is it organizes all the names, probably in alphabetical order. And so it can easily sort them. And what I mean by that is if you're a computer, and this is actually a sorting algorithm. And someone says, oh my goodness, I remember those days. That's fun. Anyways, it's a sorting algorithm. So, which means that we can become, the computer can become much more efficient if we categorize and then in a certain way to narrow down first. So like in this case, let's say we have millions of users. Let's say we're like Facebook, right? And they probably index their username field. So let's say my username is Tanner Crook. Well, if it does that alphabetically, it can look at the first character of my username, the T, and immediately narrow down those millions and millions of rows to just usernames that start with the letter T. And so then it goes, instead of sorting through or trying to find records out of millions, it goes down to trying to find records out of 100,000. And that's what an index does. And so you can imagine how that works with dates and numbers and money and all this other stuff. So we create indexes to make our databases faster. And so a lot of times, and I think, I can't remember if it's here or somewhere else, I always get a lot of questions about database optimization, or they call it tuning, query tuning, database tuning. Database tuning does a lot with design. So how are the tables created? But then on top of that, database tuning is largely in part done with indexes. So does indexes make sense to everybody how that works? And the nice thing is we don't really even have to know how it works too much, besides the fact that it does it for us. We just have to tell it to index it. Perfect. So we got a yes. We are definitely running out of time. So I know the lab instructions are a little vague right now. We didn't spend a whole lot of time covering it. However, I do think that the little amount we covered, but more importantly, we covered the actual create table statements, so that when you go through it, I think the instructions will actually make a lot more sense. Because really the nice thing is this lab, if you do follow the instructions, which, follow them, you don't necessarily have to do copy all the files over. I guess when I say don't follow the instructions, this is the one section that you don't necessarily have to do. But down here, as you follow these instructions, because it'll tell you, make sure you have the sequence, make sure you have the keys, make sure you have the indexes set up, that kind of stuff. As you follow the instructions, all these names should make a lot of sense. Now, one caveat, if you are going to not copy all the files over, some of this stuff won't work. Like this one won't work because it's got this. Whenever you see this colon, that's using a variable. So in this case, if you want, just replace colon table name with the table name that it is. So like if, for example, on this one, if I was going to do this, oh, no wonder it's not working. If I was going to put it over here, I would just change this colon table name to system user lab. And then this would work just fine. If you're doing the whole copy everything over and edit it, you don't need to worry about that, because inside of this file right here, this is where it tells it the table name is uppercase system user, which would, in our case, you'd have to change this to lab. So that's where it got confusing, is because this stuff is called PL SQL, which is outside of the scope of the class. Now, if you don't care, as long as things get created and they all show up right at the end, you're going to be good. So, but if you wanted to run the verification queries, go ahead and just change that colon table name to the actual table name. All right. Any questions? And I guess while people are typing, getting ready to ask questions, does that make sense to people? For those of you who maybe have looked a little bit ahead, does that help the lab make a little more sense? Got one yes, that's good. And I know we've been at this for a little while, so I know a few people have already left. Okay, lots of yeses. If it doesn't make sense when you get into it, feel free to shoot me a note on Slack. Feel free to watch the other video. I think the other video, while I do cover a lot of the create table statements, I think I do it a lot more in conjunction with the lab, whereas this one we kind of did our own. But I mean, I'll gauge how people handle the lab, but I feel like this way, I feel like you're going to have more of a foundation understanding. You might not have as much understanding of the lab instructions, but the lab instructions will be easier because you understand everything that's going on right here. And to me, that's what matters. And because I can always help you understand lab instructions, this is the part that's really hard to be like, yeah, understand this. And I guess just as final thoughts before we go, on that note, to me, what's most important is that you understand the material. This class, the way it's set up, is really you can end up with 100% in everything because you do your darndest, you submit it, even if there's little mistakes that you didn't catch, I can tell you and you can fix it and turn it in for full points. What matters to me is that when you leave this class and you go to get a job, that your stuff, because that's where it makes a difference. And I know a lot of you are trying to get through school, but I promise um, it is worth the effort to actually learn the material. The grade will follow. Reap the reward. If you want a really nice scripture, there's a great one in 1 Corinthians chapter 9, verse 24. It's fantastic. I'll try to share a post about it in the discussion board. The discussion board. Great scripture. I think it applies to life regardless of your religion. It's fantastic. Just great advice for life. So, anyways, thank you all for coming. Again, if you have any questions, let me know. Your questions have been great. Your comments have been great. If there's anything you need, just let me know.